Yo, Algebrainiacs! Welcome to the Johnson Kendro Video Hour!
But it's not an hour.
Oh, baby. We wish it were, but we'll just keep going. All right, we're going to solve inequalities. So, everybody knows what those symbols are, right? Less than and greater than?
Or equal to.
Or equal to with those two. Okay, here we go. It's a lot like writing equations, so let's just kind of grow from there. What inequality represents a sentence? The quotient,
That means division.
right, of a number and 3, so that's what we're dividing, is no more than 15. Okay, so
Quotient.
the number and 3. Okay, no more than. That means it has to be less than, right?
Yes.
Or can
Can
it be equal to?
Well, 15 is not more than 15.
So it can be equal.
So that's when you put the line under.
Aha.
Remember the this guy?
Yeah. You are an artist extraordinaire.
Thanks. You didn't say that on that one video where we drew
Well,
the
I'm, trying to change my life and be good, nice to people.
All right.
Okay, so look at some of the keywords. At least.
What would at least mean?
I would say it's got to be at least that or bigger, so greater than, and it can be equal to because it's at least that big. No more than.
We just did that.
Yeah,
one.
we did that one, so less than or equal to. Greater than.
That's obvious.
And less than. Yep.
All right.
Next. Okay.
Solving and graphing.
All right, now we actually have to solve the problem, not just write it. Okay, regular algebra rules. So pretend like there's an equal sign, and we got to get all the cows on one side of the fence. If you multiply, divide both sides by a negative, make sure you flip that less than or greater than sign around.
It's in all caps, so you had to read it like you were yelling.
Oh, if you multiply! Well, I might disturb the other classes. I better not do that.
It's important.
It is very important. Because otherwise your answers will be all on the wrong side of the number line. Okay, and then we're going to graph it. Remember, if you have less than or greater than, it's open circle. If you have a little equal sign with it, you got to fill in that circle.
Okay, so we're pretending this is an equal sign. Cow's got to be on the same side of the fence.
Move the 12 over.
So adding 12 on both sides.
And 3x is less than 15. Divide by 3, which is not a negative, so it's just x less than 5. Graph it.
Not like on a two-dimensional graph.
It's not a number line.
Right.
Okay, then you open circle because it's not equal to it, and then less means to the left.
Is it always like that?
Only if the x is first. If I switch that around, you gotta be careful. That one still, they say the same thing. Those two say the same thing. It's just that if you want to go the way the less than or greater than is pointing, you gotta have your variable first.
Some people do this to shade it.
Yeah, I kind of learned that way, so that's how I do it. Either one will work.
Whatever.
Yes.
All right.
Whatevs.
We
Okay, we got another example.
That's what I thought.
Okay. Oh, we got a little distribution going on here. So 5 times 2 and negative x. So 10 minus 5x less than or equal to 41. Cows get together. And
These
then,
are the same cows.
Yeah, we got 10 and 6. We got 16 cows. And then we want to move those cows to their side. So get rid of them here. All right. Don't forget the negative in front of that 5x. And then we have 41 minus 16 is 25.
Okay. One more.
Divide by negative. Ooh. Alarms are going off in
Ding,
my head.
ding, 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 ding.
Switch that around.
And I always do it before I even find the answer, just so I don't forget.
Right.
So I write the sign, and then I go back and say, okay, that's left with x, and this guy's going to negative 5.
That's why you're such a good math student.
I learned from the best.
Yep. Okay, there's our negative 5, and we're going to move it to the right, or shade to the right, and shade in the circle. Very good. Okay. All right, now we're going to set it up and go from there. So what are some of the steps we got to do? First one is identify the variables. Or
What's the situation here? What we got going on?
oh, well, we got a music service, so some
iTunes.
iTunes probably, yeah.
I really can't say that.
2 subscription plans. The first is $9 membership and $1 per download, or 25 membership and 50 cents. So these are some key parts. The word per, we talked about before, means multiply.
So what don't we know? We got to define some variables.
We don't know how many downloads we're gonna
I'm
get
just
for
gonna write
each.
songs.
Yeah, that's what I was gonna say. So good thing you read my mind.
What letter do you want to use?
S.
S is terrible to use.
All right, D for downloads.
S looks like 5.
Yeah, you're right. Okay. D looks like a backward 6. Or an upside down 9.
You're ridiculous.
Okay.
I'm moving on.
All right. We can do that. Okay, write an expression for each. So let's start with the $9 plus $1 per.
No, wait a minute. The 9 isn't a per.
Right, so $9 is what you gotta pay no matter what, plus $1 per
So it'd be like
download.
1 times.
1 times D.
Okay. That's
Okay.
plan 1. Plan 2.
2 is 25 no matter what, plus 0.5 times
Can
D.
I change it to a fraction?
Well, yeah, fractions are our friends.
Okay. And decimals are
Are
the
the
devil.
devil.
It really doesn't matter, guys. Whatever you. Oops, if it's not X, we're using D. Got me all mixed up on my variables.
My job.
Okay, what next?
So, the next thing is we gotta see, is it less than, greater than, or equal to?
So
How
it
many
says how
songs?
many songs must you download for the second plan? So that's over here to cost less.
Yeah, so the point goes towards the smaller number, so,
Come on.
yep, or the alligator eats the bigger number.
All right. All
I
right,
just wanted you to draw that.
All right, write an inequality. We did that part, and then the final thing is to solve it.
Okay, cows, get together.
What cows do you want to move?
Actually, let's do you wanna do the variable first?
Sure.
So I see a half, I probably wanna take that over.
Smaller bundle of bananas.
Yes, swing the smaller bundle of bananas.
Because you're a monkey, not a cow right now.
All right, so 9 plus a half.
That's a 9. That looks not very
Yeah,
neat.
doesn't look like a D either. It's greater than 25, and then now we gotta move the cows over. So subtract 9. So half D greater than, or not equal to, but greater than 16. Now dividing by a half.
Wait a minute. A half is the same as a 0.5 is the same as a half.
Right.
And then I'm doing 16 over 1 multiplied by the reciprocal,
So
which
it's
is
32.
yes. So D is greater than 32. What does that actually mean?
The downloads, you have to do more than 32 downloads to
To
make
the second plan, which
work.
has the initial higher
Yeah.
fee.
So if you're not gonna do more than 32, it's not worth doing the $25. You'd be better off doing the $9 one.
That makes sense. Did we answer the question? How many
Yes.
songs must you download? Yes.
More than 32.
Yes.
Okay.
Special cases.
Special cases. Okay, distribute here to get rid of the parentheses.
What do you get?
2x plus 2 plus 3. I'm going to
Cows.
put like terms together like cows. Okay, then I got to get swing
Same
the
side. I got so many analogies.
yeah, the monkey bundle of bananas. We're going to move over. Uh-oh.
Wait a minute.
We got 0 less than 5. Is that there's no variable.
No, and that's really important. It's not 0x. It's just 0. There are no more x's.
But
So.
is that a true statement? Is 0 less than 5?
Yes.
So that means no matter what I put in for x, they're all going to come out true. So any number that you substitute in, you're going to come up with a true statement.
The textbook, I don't know why, but they actually draw a number line and then they shade the whole thing. Do you need your kids to do
Nah,
that?
let's
Yeah.
just say all real
That's
numbers.
what I say too. If it's all real numbers or the other special case, which we're gonna cover right now.
You know the big symbol for real number, all real numbers
I
is
know
that
it's my
fancy
favorite.
R. I like it too. So you can use that shortcut. Mathematicians are lazy. Remember that.
Cool, cool.
All right, next one. I see some more distributing. 4x minus 12 plus 7, and then the rest. Okay, put things together. That minus 12 and plus 7 is a minus 5. Write the rest. Okay, let's move. What do you want to move?
It doesn't matter. They're gonna cancel.
Oh, minus 4x on both. So then I have negative 5 greater than 1.
Yeah,
Is that
and
true?
you could have done the numbers too, like, you know, to get a 0 on one side.
Oh, yeah.
It wouldn't matter. Negative 5 is definitely not bigger than 1. So that is false.
False. False. And that means there are no numbers for x that will work, ever. No solution.
Is there a funny sign
There's
for
a
that?
cool symbol for that one, too. It is.
That's not a 0?
No. It's a no answer, a no set, no solution.
Cool. I don't know, are we done?
Nope. Oh no, we got lots more here. Solving an and solving an or. Okay, we got two things going on. Compound inequalities. That means we're doing more than one thing.
Yes.
Okay? And means you must make both inequalities true. The or, you only make one or the other true.
So I always say, I give an example. If I tell you that I'm going to be happy if you bring me flowers and chocolate.
Chocolate, uh-huh.
If you show up with chocolate, I'm not happy.
No.
Because I said and.
And.
It might not be very nice, but I'm not happy. Okay, you gotta have both. And then for an or, I tell you I'm gonna be happy if I get flowers or chocolate. I'm okay with
Then
either.
Yes, you're a win-win.
Right. Unless you bring me nothing, then you're just in. Alright, here we go. So what we're gonna do is solve each of them individually. So just pretend they're individual inequalities that we've been solving, and then find our solution set from there. So how do you want to, let's focus on this one.
Let's move that x to the other side.
So that's x. That was easy.
Okay, and then move the 7 to the other side.
And the word in the middle is and.
Oops, you got an x instead of 7.
Oops.
There you go.
Thanks.
So, and, yep, x is less than 9.
Okay, so think about your number line. And things that are bigger than 6 would be this way going forever, but I'm not going to shade it quite yet. But we have to make this true at the same time. So maybe I should have used a different color. Let's do this. Here's my green. So if you think this is green and this is black,
Where
you make both true
at
just
the same time?
Just in between. So when we do that, here is our final solution.
Yep, and leave the circles open because there's no equal signs anywhere. So 6.1 would make it true, and 8.9 would make it true.
I also want to point out here, there technically is another way to write this, and you're going to see that sometimes. I call it a sandwich.
Mm-hmm.
When you do a sandwich, you put the small number on this side, and you put the big number on this side. You put x in the middle, and we're going to sandwich it between two inequalities that have to have the arrows going in the same direction.
Oh.
And that's written at the same time. We're going to use it actually in the next section quite often. So it's like those two separate inequalities. When you write it as a sandwich, you don't need to use the word and. It's implied.
Oh. That's pretty cool.
Yeah.
Now I'm hungry. All right, we got a big or. So one or the other. So let's move the 1 over. Plus 1. Okay, and then move the 3.
Cool.
All right, so now do our number line. Put in a 4 and a 5.
Okay.
Closed circle at the 4, and you want to go less than, and open circle at the 5 and greater than.
Does that mean it's not true because there's no overlap?
No, because it can be one or the other, so it doesn't matter where it happens. And that's what happens with the OR problems. They end up shooting in opposite directions.
Unless it's a special case.
Yes.
We'll talk about it. Also, there's no sandwich for an or. You gotta write the word.
Yeah.
Please include the word. So here's a sandwich.
Uh-huh.
It's an and, even though it doesn't say so.
Because the little numbers to the left, the big numbers to the right.
How do you solve an and, or a sandwich?
Well, you have to do the same thing, but do it to both ends. So I want to get rid of that 5, so I do it there, there, and there.
Ooh.
Cool.
So,
That's -10
all right.
and 0. And then just like we would divide by 2 on both sides, we actually do it in 3 places. Those are kind of fun.
Yeah.
So -5 less than x
Which
less
is
than
also
0.
less than 0. So remember, when you graph, think about it as 2 separate things. So here is -5. Here's 0 because I'm lazy. X is bigger than -5. Can it be shaded?
No.
Going this way, but I'm not going to shade quite yet because I also have to be smaller than 0. You can do it like that, or remember the shading like this.
Cool.
Either way.
All right. I think that's about it.
Alrighty. There's a couple special cases that come up, but we'll mention those in class.
Yeah. All right. This is a little bit of a shady subject, but we hope you understand everything and enjoy it. Ta-ta. I had a